I'm going to talk about security IoT. It seems like an oxymoron because there's so many unsecured IoT devices. A quote I heard not long ago, which I actually think is quite fun or interesting. What's the difference between a gas stove and a bomb? Just security. You can easily turn a gas stove into a bomb, and many of people probably have that at home. Today we connect everything. We connect light bulbs. We connect cars, we connect traffic signals, we connect oil refineries, nuclear plants, whatever. We even connect life-maintaining devices such as pacemakers or insulin pumps. They are all connected to the internet today. And why do we do that? Because it actually do provide value. Now we're talking the business term, right? It does provide value. It makes our lives easy at home. If the vacuum cleaner can tell me on my app or whatever when it needs to change its back or needs service or whatever, that makes our lives easier. Manufacturing. If you can figure out when a device breaks down or before it breaks down, you can increase machine utilization. You can even reduce waste when you build system, and then eventually probably help the environment. There are also actually IoT solutions that does that, minimizing traffic. For instance, consider garbage disposal, which routes are they supposed to take you. They don't need to come to my house this week because I'm not home. Unfortunately, the internet is full of bad people. A lot of bad people roaming there that tries to, trying to attack your infrastructure, IoT or otherwise. So we need to make it virtually impossible. We can't make it impossible, but virtually impossible to compromise these devices. Security is not only about data and privacy. It's also about, it has turned in with IoT. It also has to turn into like physical security. Let's think about again a car. There have been some interesting breaches with car manufacturing, and if you look at the car manufacturers today, most of them you buy today, or even the last 5 years, are connected. You just don't know it. You don't have access to data, and they're not telling you. All right, I'm Anders Lybecker. I work for Microsoft. I work with IoT. I'm an engineer. Don't sell anything. I just build things. I found this tweet not long ago on the internet, and I still love it. It's probably the best one I have ever seen. And there's a lot of truth in it, because every week there's a new fairly major incident. But I also, on top of this tweet, I just added a Google Trend search graph on IoT security for the last 5 years, which is quite interesting. And there's a peak in the middle here. Anybody can guess when that was? Mirror? Yeah, it actually was. There was an attack in October 2016, which took down the internet on the east coast of the US the most part of a day. We didn't notice it here in Europe. It was basically a simple botnet attack with about 100,000 consumer devices. It was DVRs and security cameras was also part of it. And the devices origined from the US mostly. And it took down DNS, which is the primary DNS service apparently in the East US. So critical things like you won't be able to go to Amazon to buy your stuff or watch your Netflix or go to Twitter. All of that on the east coast of the US was down for the most part of the day. So that was a major incident, which the day that happened actually made it to even New York Times in the technology section. But it has a major impact, so even the political side started discussing it. So the day after was actually in the political section. So you see these, even a simple, small, even though 100,000 devices does sound a lot, it's a small attack, can have socioeconomic concerns. Imagine today, the amount of devices connected. A future attack could easily be 100 million devices. What can they take down? Future attacks could cause liability issues, kill a person. If you look at medical equipment, most of it, or much of it, is already connected. If you reverse a pump in an oil refinery, what will happen? The gas stove again. The fun thing about the incident was the IoT industry here. The response was very inadequate. The solution to that problem with the mirror net was don't connect your internet, don't connect your device. And the actual problem was even more horrifying. It was default password of password. So it's very easy to crack about. You just search internet and find all the devices that was exposed, and you root password, then you're in. Okay. Number of vulnerabilities. This is a graph of the number of vulnerabilities since '99 in the Linux kernel. And you can see the number of critical vulnerabilities is risen recently. I work for Microsoft, so I have to add another two, not because I want to, but Windows and Windows 7 also has recently seen a huge increase in number of vulnerabilities. And if you look at Mac, it's also there. But we can't really compare because this number of vulnerabilities, not the severity of the vulnerabilities. But what I like is the trend, right? We haven't really thought about it for years. Not really. Microsoft started like 10, 15 years about thinking about security. Before that was nothing. But recently everyone has tried to mitigate all these kind of risks. And we should be doing the same things because now our infrastructure is not only our gaming laptops or our work laptops or email servers that can go down, but it's traffic lights, it's oil refineries, it's ships, it's everything, even in your car. So we need to look at a couple of things here. I'm going to go through I'm going to show you a couple of demos. I'm going to talk through the process of securing hardware and stuff like that, and even software. I'm not going to go through how you develop secure software. I'm pretty sure that's hopefully well known in the software world. I'm a software engineer, moved more or less into hardware a little bit, so I have a combination of knowledge of these two, and that's why I'm trying to convey it to you. So one thing that you never think about is the silicon secure. Is your board, is your tiny things here secure? You should think of these things as your packages, like your NuGet package or NPM packages. You need to know what's happening in here and need to verify that it's secure already. Is the OS secure? Yeah, we all know that one. Everybody is hopefully updating their OS. Can you perform device management? I'm going to move into that a little bit later. And then there is this one, tampering proof. You can't make it proof, but you can make it so difficult that nobody really touches it. If you look at security cameras, there's actually one up there, and in the ceiling it's difficult to see. They are built like a dome because they're really hard to break. You can take a hammer and it won't break. And that's one way of making that one tampering proof. You can even take it down from the ceiling and then disassemble it, but it is difficult to do. And in general, if you have any of these problems, you have something to mitigate, and everybody has something to mitigate. I'm going to split the focus a little bit into two areas, because there's consumer IoT, which you and I see. Consumer IoT like your phone or wearables or smart home appliances, whatever you have at home. And then they're in the industrial IoT, because these two very, very different worlds. Industrial IoT can be logistics like moving stuff from A to B, or manufacturing, which is a major part right now. Grids like utility system, electricity grid, or internet for that matter. Health is also a major thing, and especially one that you need to take care of when you're looking at security. Grid, yeah, you're out of internet without power. You're gonna be pissed, but you're not gonna die. And if you look at the IoT industry, what you see is basically consumer IoT, which is so minute part of what IoT actually is. Yes, wearables is a fun, and all the geeks here in the room probably has one or two, and a lot of other devices. I got at least 50 devices at home, and counting Raspberry Pis, whatever I have at the table here. Most people won't have it. I'm a first mover on Philips Hue and all that kind of things because I think it's fun, but my mom definitely doesn't have any of those, not even my brother. So yeah, and the focus for these two worlds is very, very different, because if you look at privacy, at least, I'm sorry to say, even with GDPR, IoT manufacturers are still not concerned about privacy, and not at all. electric toaster at home. What kind of, if you know how often you utilize it or how long, is that a privacy? Is that a privacy concern? Probably not. But if you could go into an industrial world, if you can get data out of a robot that assembles, I don't know, a car or a toaster, you can actually figure out how they are built, how many they built, and that's something that the companies want to keep safe. Security, it has some focus now, as long for consumer IoT, as long as it's not difficult to use. Again, industrial IoT, security is one thing. They are actually struggling a bit whether or not to connect devices now. They see the value, but if you talk to the operations department, they are just, we don't want to connect anything to the internet because that machine is like 25 years old and we haven't updated it. Life expectancy. Most consumer devices you buy does not have a life expectancy more than 2 years. I myself believe it has to do with the guarantee that when you buy something in Europe, you have to the guarantee lasts for 2 years, and when it's just like those 700 days old or something, it'll break. Most of my things do. No, that's not true, but some of them do. And in industrial IoT, you'll see devices running for 25 years nobody has ever touched. So if you build anything in industrial IoT, you have to think 25 years ahead. What kind of tools, what kind of things could people think of when they're trying to attack a device? It's really difficult. It's like being a magician. I'm not, so I can't help you there. But we can apply the best practices we have here in security today. And then there is actually another point in consumer versus industrial IoT is the price. Yes, I'm a first mover. I paid a lot of money for my Philips Hue or whatever it was, but I will not pay 20 extra euros or anything like that for an intelligent coffee machine or anything like that. I won't pay that, and neither will many of you. Industrial IoT, yes, they are cost aware. They need to make money, but basically it's not really a problem. If you come in with a solution, you can prove that secure, that brings them value, which most of them does. It doesn't really matter if it's 1 million Norwegian kroner. And just to move this a little bit further down, there is a lot of different IoT devices. IoT is a business term. In my opinion, it's not a technology term. We had M2M for a lot of years, but IoT has just become a business term right now. But there's different kind of devices. There's these minute microcontrollers, or there is even phones or PLCs, which you see in manufacturing and production lines, or you can even see servers like racks considered an IoT device. And they have, of course, they have different costs, they have different compute capabilities or memory storage. One of the things I often see if you buy at least a consumer device is they want to minimize the cost in general, and that has to do with components, what kind of components you put in, and of course the CPU size and memory. That's actually an interesting spectrum here also called energy consumption, because some devices, if you look at smart cities, smart buildings, are battery driven. So they put light poles here in the city probably connected, or some of them are if they're playing with that. They run on batteries. And if you put humidity sensor under your sink at home, they are probably battery driven. You don't want to have an electrician drag a wire through the house because it will cost you a fortune. You put a battery humidity sensor underneath your sink, and then you can get lower insurance premium, because that one will send a signal as soon as the humidity increases more than what a level that is. And that battery and that device is supposed to last. You can get devices that last 10 years that even sends out humidity or temperature. That's pretty amazing, but that you really need to cut down on your energy consumption, whatever you do. So running a Node.js app or C# or Java is totally out of question there. Okay, so we all know that privacy matters, and I think, it's a major topic in European countries right now. But there's another topic that we need to consider, especially in IoT, is integrity. And what do I mean by integrity? You need to be able to trust the device, the data it sends you. Otherwise, you'll take the wrong business decision. So if you have 1 million sensors out there and you can only trust 10% of them, but you don't know which one of them you can trust, what are you going to do? You're not going to trust any of your data. So we need to build that into the platform too. Okay. This is a huge slide. Don't really concern yourself much about it, but we need to things that we need to do. We need to, first of all, we need to secure the device. Then we need to secure the connection, and then we need to secure the where you store the data. I'm going to skip the data or how cloud whatever part because I'm pretty sure that most cloud manufacturing they got that nailed. But securing the connection and securing the device can be a little bit challenging, and I'm going to show you how a way of securing it. So let's start with secure the connection because that's the easy part. If you have a device, in my case, a lorry or a truck, and a network, an internet, and a cloud, whatever, you normally, the way you normally would secure that system is building a private network. IPsec tunnel, VPN, a VLAN, whatever you want to deploy here. And that's doable. The problem with these devices, these small devices, is they are minute. They don't have much processing power. Most of the devices I've brought here today is Raspberry Pis, and they have huge amount of processing power compared to what you normally see in the field. So if you have a lot of these, each one of these is an easy target to get into your network. So you need to deploy another defense strategy. And that is, instead of having a million small devices, a million truck lorries, minute compute, Raspberry Pi kind of things to be out of boundary, you need to have a central point that has the compute power, the capabilities of doing intrusion detection, authentication, denial of service attacks, monitoring, all these kind of things across all your devices at one point. And build a network between the device and that one, the device and the gateway in the middle. If you do that, if one of your devices is compromised, it's only that device, and hopefully your intrusion detection or monitoring will figure it out and say, okay, I don't like you anymore, you're not part of the family, and shut it down. Or at least close the connection and say, I won't receive any more data from you. And one way of doing that is Azure IoT Hub. There are other vendors that has a similar concept. I work for Microsoft, so I'm going to show you Azure IoT Hub, and that's where my expertise are. And one of the cool things about Azure IoT Hub is the bidirectional features. So you're not the device is not only able to send messages to IoT Hub and to your business system, but you're able to send the message the other way around. There's a couple of other features I want to show you. First of all, support millions of devices, like literally millions of devices, just for one IoT Hub. And the first SKU costs $25 a month, and then you can have millions of devices connected to that one. Multiple languages, open source SDKs in Java, C++, Node, whatever. If you don't like to use the SDK, you can use directly the protocols we use underneath, which is AMQP, MQTT, which is the standard protocol used in the IoT industry. Has a number of other features, like send telemetry, meaning sending data to the IoT Hub, receiving commands, device management, blah, blah, blah. I'm going through a little bit of these kind of features. Billions of messages, you can send as many as you want to, basically. Today, or the last number I heard, which was, I think it was January, we receive about approximately 2.5 trillion messages through IoT Hub per day. That's quite a big number. It's a software as a service. You can scale it up as much as you want to. At one point, you need to call Microsoft and say, I need a huge machine, but you can. Has a number of other really nice features, like we talked about intrusion detection. There's integrate to the security system of Azure already, so it utilizes many of these services. Nice thing, it has per device credentials, or certificates if you choose to use that. You can enable or disable a single device. It requires a secure tunnel, so that's we solved the network. And it has some other features like you can be able to do device management, firmware, software upgrades. Not only that, there is, especially if you look in manufacturing, you often see that they have a firewall. Most people have a firewall, and that's the one here in the middle, showing you have an isolated network, and these small circuit boards are supposed to represent the devices. And each of these devices should be able to talk to the service gateway, which in my case before was IoT Hub, but it could be one of the other vendors. And then over here have a client, which is the management client. But these devices does not actively listen for any traffic. They only create an outbound connection to one instance, and that's the IoT Hub. It's actually we use the SDK to build in, so you can't really connect to anything else. And it's only allows outbound connections. And each device only allows outbound connections. There's two different things here. There's devices here in the bottom that are IP capable, and then there's minute devices doesn't even capable of talking TCP/IP or UDP. They have to go through a field gateway, otherwise they can't traverse the internet. So you have this firewall. The firewall blocks any incoming traffic, allows outgoing traffic on a set of ports, depending on the MQP or MQTT. And the gateway is the only addressable point. And that has the power of Azure, of all these kind of intrusion detection systems. So if you need to talk to these devices, you have to go through the device. And each of the devices can't talk to each other either. They can only talk to the service gateway. So that's the software-assisted communication pattern, which is actually quite nice. You can, if you want to, have each of the devices have a persistent connection, meaning you can send messages directly from the IoT Hub, the service gateway, to the device. Like say, okay, change the temperature of the room or whatever, if they keep a connected persistent connection. We do have queues built in, so if it's not connected, it'll just be queued. And then whenever the device wakes up and connects to the IoT Hub, it'll get the message. Okay, that was the network. So now we need to secure the device. One way is to put it behind these metal doors and keep it there for a long time, so it rusts, so you can't open it. That's physical security. Let's look at some of the credentials, because yes, we secure the network now. We think about securing the silicon. We thought about other kind of things, but we need to have a certificate at least, or a set of credentials to connect to IoT Hub. How do you secure that? Where do you store the certificate? Normally, you would do something like encryption. Okay, let's encrypt the key or certificate, and then store it somewhere. Where? We could store it here on my Raspberry Pi. It has a memory chip, but it's really easy to steal and really easy to run away with, and it's really, really easy to replicate. I work with a client or customer in Holland, and it wasn't a chip you can remove, but they had an issue with the system where they were Asian company replicated their product, so they figured out that one of their devices suddenly, instead of sending message 10, 20 messages a day, send 4 or 5 million messages a day. That's because the replicator has just replicated everything, including whatever was on the memory. It was easy to solve as they had per device credentials, so you just kill that device. So there's one customer in Holland that was really pissed, and 4 million in China or wherever it was sold. But we need to solve that, and we need to solve a couple of other things. So yes, we need to be able to store secrets and keys somewhere, but while we're at it, we need to be able to ensure that the firmware on this device is secure. We need to be able to verify that the software is the one we expect it to run. It's not a modified version. So therefore, we need secure boot, and therefore, if we do all this, we actually can also do device attestations, or this is actually the physical device that we expect it to be. And the solution is actually quite simple. Every one of you uses a trusted platform module, or a TPM chip, as it's called. You just don't know it. My laptop has one. And if you, for instance, store your the Windows credentials is stored in that TPM chip. If in Chrome or any of the other browsers store your username, or not username, password, it's stored on the TPM chip. And TPM chip has some awesome features. It's a minute little chip. I have a couple of them up here on the board, and I'll show you in a minute. They have secure storage. They have key and certificate management. You can actually ask it to generate a key, but you can never, a certificate, but you can never extract the public key from it. But you can use it to encrypt the message or sign a message or whatever you want to. And has some platform integrity measurements so we can detect if it's modified. It's nothing to do with Microsoft, by the way. It's trusted computing platform. Microsoft is part of driving the standardization, but it's even in Chromebooks and phones, not all phones, but some phones. I had to change a little bit here, my slide, because it's not version 1.2. It's the current version. 2.0 is the current version of the trusted platform module. And how it works, let me show you. This is your silicon. This is your board, whatever it is, with the dotted line here. And you have a TPM chip, and the default TPM chip is locked. You can't read it, you can't use it, it'll just won't talk to you. So the device boots up. For instance, Wi-Fi is a secure boot, which is part of all machines today, large machines at least. You run the bootloader and the kernel loader drive, the kernel loads, and which loads system drivers. And all these input, they're called measurements. How they are, if I have links to the specification, we'll get more in details, are measured. And if any of this has changed, the TPM chip doesn't like you anymore. And it'll say, okay, there's something wrong with this system. You can't read anything. You can't use my certificates. You can't read my secrets. You can't read any of that. And there's a second part, and that's the device attestation. And device attestation is actually quite simple. It's a hash of your chipset, your memory, your whatever things you added onto the board. So if that's changed, it'll complain. Actually, the same feature we used when you, it's not a problem today when you have a laptop which can't change much, but in 7 years ago or 10 years ago when you built your own computer and you switch out to CPU, then the first thing Windows would do is complain. Yeah, something wrong. Your machine has changed. And the same features you used. If all this match, the TPM chip is open. And you're able to read content from it. And then, of course, authorization against the TPM chip and stuff like that. But I'll just show you here that I have my third-party app running, and I'll show you in a second on a device I have running here. So I'll be able to, as the third-party app that's verified, to be able to read the TPM chip and get the credential and connect to the cloud and send some data. A really simple scenario. So let's show you how it works. First of all, I'll do like, all right, I'll show you this first. This is the Azure portal. I have an IoT hub here, ALY hub, and it has a couple of devices. And both of them are actually connected right now. And this is the massive scale one. I'm running the tiny mini micro one that costs $25 a month. And I only have 2 devices here, a Raspberry and a Windows IoT device with a TPM chip. And if you go to the second browser, you'll actually see that one of my devices, I'll show in a second, is sending data, just random data. It's wind temperature, there's no wind in here, and I don't have a wind sensor on it, I just generate a random data, and I push it through IoT Hub and over to Power BI just to visualize it. I want to show you get some data through it. And the device is here. This is a Raspberry Pi, nothing fancy or anything like that. And on top of it, I have this hat, which is a TPM chip. And actually, the little chip is that small black one there. And that's the one I read the credentials from. And the way I do it is actually quite simple. So if we go to, now I've written it in, but just because I wanted to show you I can run Windows IoT, it has nothing to do with, it is simple to do. So I've created one here, but I could easily have done it on a Raspberry and with Node or C++ or whatever you wanted to do. But just to show you how easy it actually is to use, I've of course installed a package, a NuGet package, that contains the implementation of TPM device. I state here I want device slot number 0, and then I just get some properties like where I'm supposed to connect to, what is the device actual ID, and then I generate a time-based token that's valid for an hour, and then I connect to the IoT Hub. And down here in the generate current wind, you can see my awesome randomization method. So that's all it requires to secure the connection to your device. So for instance, if I unpower this device, take another one, It runs with totally the same implementation, same app, everything except the credentials are of course not stored. The credentials are still stored in the board. Sorry, in the TPM chip. And if I connect that one, you should be able to see in the back of the screen also behind the camera that there's no data coming through right now. It'll take a little bit time for it to boot up, no more than 15 seconds or so. But it'll already fail right away because device boot and stuff like that should be the same, but the hardware attestation will fail. So even though how long we wait, you won't see any data arriving on the Power BI Bash dashboard here in the background. So that was an easy way of securing the credentials and do hardware attestation, all that kind of things, just by applying one of these TPM chips. And if anybody have followed, for instance, TPM chips a little bit, they will ask me about ROCA. Nope. None? Okay. Last year, about November, I think it was, October, ROCA was a breach, or not a breach, they found a vulnerability in the TPM chip. Actually, not in the TPM chip, it was in the library used inside the TPM chip, because the TPM chips have firmware, of course. So that actually meant that you could, from the public keys, deduct the private keys, which is not good. So they're not secure anymore. So that was sort of a problem. And it was Infineon that wrote the library. So all the Infineon chips were, I have one here, had vulnerability. But it was not only Infineon, but many of the other manufacturers, because they actually utilized the library. It's not a problem anymore, at least if you upgrade it. Windows automatically have, a long time ago, automatically upgraded your firmware on the TPM chip, even if you just run the normal Windows update. Otherwise, you need to figure out how to do that. And it was not easy to deduct the private key, but it was doable. And if you had only had 250-bit long key, it was actually quite easy. I could do it on my machine in less than half an hour. Okay. If you wanted to work with TPM, it's actually, I showed you the .NET standard implementation, which is awesome easy. The same is actually with the C++. I've only used the Microsoft libraries, but there are others out there, and you can read the specs there if you want to. The only problem with TPM, besides it works awesome, and there was a security breach not long ago, but that's been solved, is its costs. And we talked about consumer IoT. I mean, we talked about consumer IoT, we're very cost aware. But there's a new standard coming up. It's been out for 2 years called DICE. It's also about the trusted computing group that delivered that one. And the cost of a TPM chip, even though you buy the bulk of 1,000, they're still close to €1 per device, which is a lot in the bill of material. And I've actually also brought another one. I've brought a DICE device. I'm not going to demo it because it's very, very similar. It's just different implementation. I just need to find the camera here. This is a DICE development board. It's quite expensive because it's development board. I paid $150 for it, but I just wanted one to play with. And it has the same capabilities, but costs way less. We're down into 8-7 cents per device. All right. All right. All right. So now we've done all these things. We figured out that the TPM chip had a vulnerability, so we need to figure out how to update these kind of devices, and the firmware, and the software, and all these kind of things. And another tweet. There's some truth to this, especially if you look at some of the devices I have at home, including some of my Raspberry Pis here. They're not really updated, but they work. I'm awesome. I'm happy. I need to say that Swift on Security is InfoSec's fun Twitter channel. So it's supposed to be Taylor Swift talking about security. So sometimes they tweet weird things like Taylor Swift would probably do if she knew as she doesn't know anything about security. So it's quite a fun channel to follow. There was a study in Microsoft done a handful of years ago, where they looked at software components vulnerabilities of consumer devices, and they figured out that, for instance, a router has 102 third-party components. A thermostat had 7, and a TV had 12 components. And if you build a system and you take some of these components, like you do with your package manager today, you need to make sure that they are not they are mitigated their security risk. So updating once in a while, but that was the problem here in this case. And if we dig down to one of them, it's a smart TV. It was from 2012. It's old. It cost about $3,000, and a flat panel LCD TV apparently has a life expectancy of 100,000 hours, which, on average for an American user, is 11 years. But unfortunately, even though the product was released in 2011, the last firmware update was 2013, 2 years after. Funny. So they actually looked at the vulnerability of this single device, found vulnerabilities, and it was launched in 2011. They already had a bunch of 25 vulnerabilities that wasn't fixed, and by the end of the last firmware, the number have grown. And even just if you look at the 5-year period or 4-year period, more than 500 unique vulnerabilities had arisen from that single device. I have an old TV at home, and when I saw this one, I haven't thought about it before. I unplugged it. It's not even smart anyway, but it was plugged in because it could take care of itself, update its firmware, but it didn't. So that's interesting to see. So we need to be able to do that somewhere. So I'll just put this up just for fun. How many of you have any of these devices? That's like 15, 20%. All right. How many have updated within the last year? Keep your hand up if you've done that. 1, 2, 3. Now we're down to 5 or so. All right. That was interesting to see. All of them had security vulnerabilities within the last year. And if you hadn't have one of these devices, you have been hit anyway within the last year, because then crack came along, and we talked about the TPM chip. It also came along, which basically rendered VPA2 insecure until you updated the server, your access point. I have updated my access point at home. I have updated all my devices. But anyway, just to show you that you really need to be able to, whatever you have out there, as soon as you connect it, as soon as it has the capabilities, you need to be able to update the device. Because then in January, we were all hit by this one. And everybody was concerned, and we're not thinking about it anymore. It's hopefully been mitigated. All right, so we need to be able to not only upgrade it, the device, we need to be able to, why not elevate a little bit to do device management. And there's a couple of device management. Most of them has to do with like firmware upgrade, being able to reboot afterwards, because that's what you need to be able to create a new bootloader and stuff like that. Factory reset, it's a nice feature. You need it once in a while. Configuration, why not? It's a simple thing, like being able to push down new configuration. And then, of course, software updates. I'm going to show you some of the things, how it works here in IoT Hub. So consider this. In the middle, you have IoT Hub. On the left, you have a device. On the right, you have your backend, your management system. And IoT Hub has a feature called Device Twin. If you ask some of the other manufacturers, some of them call it Device Twin, others call it Digital Twin. It's the same concept. So if you want to talk to the device, you can actually set properties like do something, update the frequency of sending temperature. So you can do that from your backend. It'll propagate down to the device, and as soon as the device implements that feature, it'll send back to the reported. And then your backend can figure out, yes, this device it has changed the configuration value. Sorry about the tags in the bottom. It's just a way of you can organize your devices. All right, so let's look at firmware upgrade. Okay, firmware upgrade, an update. We use the same feature, so we can from the backend. First of all, the device needs to be able to have the capabilities of doing a firmware upgrade. So you need to have some piece of code there running. So you send from the backend to the device saying, okay, do upgrade your firmware. This is where you're supposed to pick it up. This is what you're supposed to do. The operator dashboard is updated, and the device will send back information and say, okay, I'm started downloading, I'm doing this thing, and if you've got a slow connection, it's going to take you forever. Especially if you look at some of the other sessions that was yesterday about LoRa or narrowband, or Sigfox, which can sell 12 bytes at a time. That's going to take ages if you wanted to update anything. The device will show you, I will again report the status, I'm about to apply, and I will soon reboot and all this kind of thing. And the operator dashboard is updated all along the time. And I would like to show you that, how it works. So if you go to the camera again, it's not really fun to see, but the white box here also runs a Raspberry Pi, and it runs Raspbian, and that's one of the other devices I have connected. And I have created an SSH tunnel into it now, so I'm at my device called Node-RED. So I have a small application running here. It's like 100 lines of code or so. And basically what I did now is just connect it to IoT Hub. And then I have my device management client and backside in the backend that's also connected to IoT Hub, and that can send commands down through. So I can call that one, for instance. I've written an executable that takes a parameter, which is with the device identity, which one is I'm supposed to update. I'll actually go quite fast through here because we've got an error. That works anyway. Awesome. So you can actually see here, as soon as it acquired the device twin, where I had the specification here on the right, where it said, okay, download it here from downloads.raspbian.org/Raspbian latest. I got the status back. As soon as it went to downloading, it was quite fast. I got it over here on the right side. It said downloading, or actually here, down to the next line. And then as soon as it started, finished downloading, it said download complete. And then applying and stuff. The only thing I haven't done is restart it, because then it'll ruin my demo, because it will disconnect the device, so it's not fun to see. So that's seeing how easy it is actually to do a firmware update. And you could use the same to do configuration changes or software updates. All right. If you have a massive amount of devices you want to roll out, and how do you do that? Because you need certificates, these credentials into all these devices. You can, of course, buy them pre-configured from the manufacturer, but then the manufacturer will know the device identities or the credentials, all of these kind of things. Or use a service, it's a fairly new one, I think it's about a year old, called Device Provisioning Service, which is a standard way of provisioning, configuring devices at massive scale. And it's awesome marketing term here, zero-touch provisioning. You can use your own URL, and it's actually quite easy to use. The concept is quite easy to use. So here you got three things here. You have your devices in the lower left corner. You have the device provisioning service, and you have your IoT hubs. And you can have multiple of them, because you don't want a device in Australia to ping back or to connect to a device or to an IoT hub in Europe, for instance. So how does it work? You go out and buy your silicon, you buy your TPM chips or DICE devices. Let's pick that one. And from the manufacturer, you get device enrollment information, like the credentials. You register those in device provisioning service. As soon as the device comes online, the first thing it's going to do, here I am, I'm this guy, connect directly to the device provisioning services, present the credentials, and then the device provisioning service will look up and say, okay, apparently you belong to customer A. And customer A has this IoT hub that it would like you to connect to. So register the device to the IoT hub. And the IoT hub will send back a new set of credentials, which will be stored in the device. So now the manufacturer doesn't have access to the device anymore. Then I'll establish a connection to the IoT hub. That the initial configuration might even have firmware upgrades or software upgrades before that. And as soon as that's done, it can start sending data. And then we can use the normal flow we can do in IoT Hub. The data is sent to some business logic that figures out that you need to change something, and then you send back the inside configuration change, whatever it is you want to do. So that's actually a quite nice service to use if you need to roll out devices at scale. Okay. So we established that I've been compromised within the last year. Most of you at least have. So I can claim that everybody has been compromised within the last year. And I'm not doing a good enough job helping the world. I'm not the only one. Helping the world to secure all these kind of devices and mitigate these security risks. Microsoft released a paper last summer called The 7 Properties of Highly Secure Design. Secure devices. And it basically has to do some of the things we went through. Hardware-based root of trust. You need to be able to trust the device. What kind of firmware, what kind of devices, what kind of chips is on board. Small trusted computing base. Also has to do with, don't run a Raspberry Pi anywhere except that it's a hobby project, because most system doesn't need a USB port. And the thing that you can take the memory chip out that easy is just silly. It's not even production grade. Defense in depth applies to software running IoT devices as it does everywhere else. So if you have two processes running on the service, they should authenticate them each other. Certificate-based authentication, renewable security, be able to exchange the keys once in a while, like everywhere else. Be able to report back when the device thinks it's been compromised, or at least being able to detect it at the server level, or the cloud level, IoT Hub in our case. All of this is built on a number of standard papers that's been out there that we have incorporated into these 7 principles. I have a lot of links in these slides, which of course you'll get access to. And all this has been implemented recently into something called Azure Sphere. Azure Sphere is a hardware design from Microsoft. We don't produce the devices, a lot of our partners do. The first public preview will be available September, I think. It's a secure MCU, and an MCU, for those who don't know, it's not a board, it's actually the microprocessor. Think of something, and it's not in the scale of a Raspberry Pi, it's the scale of Arduino divided by 100. And these devices are specifically designed to run, for instance, small scenarios like intelligent fridge, doesn't require much processing power, or a toaster or anything like that. So not meant to be running high industry grade yet. Right now it's Cortex-A processor. Cortex-M will also be available, which makes it even require less power. So all these 7 principles are actually part of it. And one of the fun things is actually we supply a custom Linux OS by Microsoft, supported, full support. And the awesome thing about the new Microsoft is this is royalty free. And it doesn't even have to connect to IoT Hub. It even can connect to any of the other competitors like AWS or IBM or PCT or whatever it's called. And the only thing that it has to do if you want to have all these kind of features, like updating, it has to at least connect to IoT Hub once in a while to get the latest firmware, because that's built in. You don't have to write any code. It'll automatically update the firmware and all these kind of things that you expect it to do. And it has security monitor, automatically send that back data also if it's that we can use for intrusion detection or whatever it's supposed to use. The things I haven't touched is sort of like a development process, both hardware and software. And there's a lot of slides here, and some of these documents are fairly long, like threat modeling, which is software securing software. Go check out these links. If you want help with it or attestate your security, Microsoft and our partners is actually helping out doing that. And I know in reality, not every device should be really secure. I started up talking about a toaster sending data to IoT Hub. Yes, Toaster is not really a privacy concern, but let's think about your electricity usage or water usage. Is that a security concern if anybody gets access to these data? Yes. Yes. Hell yes. You can actually figure out when people are home. You can figure out the pattern. I go to work every day at 8, come back at about 4. I haven't flushed in 3 weeks. I'm probably on vacation. So you can actually, all these kind of data you can deduct from devices that you don't think you can. So this is Industrial Internet Consortium that just recently released this security maturity model. So you can certify your devices at a specific level. So level 0 is, of course, I don't care. No security whatsoever. More or less like most of what I do. For hobbies at least. Then there is level 1, where you need to ensure the transport of the data is encrypted. Some form of device identity that could just be storing your credentials on your SD card, for instance. Level 2, where you need to have secure storage like a TPM or dice chip. Hardware-enabled unique device identity, like I had with my first demo, where the Raspberry Pi, I moved the TPM chip from one to another, and then all IoT help just said, no, I don't like you anymore. And auditing and monitoring is level 3, where the actual SENDAC data, if it figured out it's been used, or if the security camera, if you can detect that the glass has been breached or something like that. And then level 4, real-time monitoring. And really depends on what kind of industry you are aiming for, but at least level 1. Preferably go a little bit higher when you're building IoT devices. Yes, Industrial Consortium. So what I want you to take away from this is you need to secure your device, tampering proof as much as you can. And it's not that difficult, it just requires a little bit of thought process. Use secure hardware elements such as TPM or dice, or even Azure Sphere, which is based on dice. Secure the connection per device, connection string, certificates. Don't share it across multiple devices. Use software-assisted communication is actually quite a nice implementation. And if you go to industrial manufacturing and you show them that, they think, oh yeah, that's actually quite nice. And then you show you some of the features of the cloud providers, what they can do in intrusion detection, which is way above what most companies can do, are capable of doing. You do have to have device update. I know that in some industries it can be really difficult. I just briefly mentioned Sigfox or LoRaWAN or narrowband, where your bandwidth is almost non-existent. That's a problem there, but some of these, for instance, Sigfox and LoRaWAN, as our proprietary hardware implementation of the security protocol, but do take a look at that, and we can talk about that also afterwards. Configuration updates is just a nice thing, and fast factory reset is also a nice thing, but as soon as you can connect, you might as well implement these kind of features. If you haven't listened to anything I've said today, there is also another way of doing it, and then you need to listen now, or at least read now, because that's the only way you can make it 100% secure, not connecting your devices at all. There's a lot of numbers coming out recently about 20 billion or 5 billion or 200 billion devices, but there is a lot of devices connected. I've worked on projects where we had hundreds of thousands of devices connected. For instance, I live in Copenhagen, and all the street lights, so 180,000 of them are connected today. It's not a problem if they get compromised. Security is okay because I helped them, but it's not really a problem, except that it will not be a light in the city for a few days. But all I want to say is thank you, and if you have any questions, just yell them out. Tell me. Or you can reach me out at my email or Twitter, or I also have a blog called Lybecker.com. I don't write that often. And of course, we'll make the slides available. Any questions? Yeah.
How do you relate to the telcos and, for example, narrowband IoT?
How I relate to the telcos and narrowband?
From a Microsoft perspective.
Okay, that was actually quite an interesting question, because I work with the telcos, some of them, not all of them. And we are in the process of building integration between LoRa, Sigfox, I think some of it is already there, and narrowband directly to IoT Hub. So you can, the hope is that we will create a secured, let's say, tunnel between all of it. So your device and your certificate and stuff like that is managed in IoT Hub, but it is in the early stages. And I can't promise we will ever succeed because we are in the early stages and I'm allowed to talk about it because I'm not part of, I'm not bound by the, so we are trying to build it, but in reality we do have a prototype running, but by the end of the year, we might have something, but we might not.
Do you have any thoughts on how to simplify the connectivity part or registering a new device?
How to register, simplifying register a new device. Are you talking about narrowband and LoRaWAN again?
Yeah, narrowband.
Yes. Yes, we do have some thoughts. Whether or not they can be implemented so you can easily register a narrowband or LoRaWAN device is not as easy. It has to do with a couple of implementation specs of how they work, and also a feature like an IoT Hub, which I'm working on removing. So I hope we will. That's at least the goal. We don't just want a simple connectivity so you can get data through the device. We actually want device management, so we don't have to have a second portal. It's specifically for LoRaWAN, which is built differently. So LoRaWAN is a proprietary protocol. It doesn't do TCP/IP or anything like that. So when it sends data through, there's a number of certificates, and they are managed. There's a network certificate making sure that the device only connects to the right network, but there's also a data certificate. So when you send the data, that's secured. The problem is today, the implementation, that most narrowband providers actually, they have both certificates. So they can easily inspect your traffic. And that's some of the things we're trying to solve. And we actually have sort of the same problem with narrowband. But I can't say we hope we're going to solve it, but I don't know. Any other questions? Thank you then. I hope you enjoyed it.